Math 8, Unit 5, Functions, Lesson 10, Interpreting Elements of a Function in Context. We're going to look at a bunch of different functions and interpret some things about them, like slope, intercept, and ordered pairs. And so for each of the following, we're going to interpret the slope, the y-intercept, and some other ordered pair. Our first equation, y equals negative 3x plus 6, where y represents the distance from home, measured in miles, and x represents the time spent walking. Now the slope is negative 3. What it means is the person is walking at 3 miles per hour towards home. In fact, the negative is having their distance from home decrease, so that's why it's negative 3. The y-intercept, 6, it means the person starts 6 walking miles from home. They start walking 6 miles from home. That's got a little bit of a typo in it. And then what does the point 2, 0 mean? Well, that's inputting 2, where x represents the time spent walking and y is the distance from home. This means that after 2 hours of walking, the person arrives at home. They'll be 0 feet from home. Interpret the slope and y-intercept of this one. The equation y equals 25x plus 1,050. Y represents the cost of rent, and x represents the number of days late. The slope means, well, it's 25. It means the late fee on rent is $25 per day. Notice that the slope has a rate on it, and that rate is y per x, in this case dollars per day. The y-intercept is 1,050. Rent is $1,050 when it gets paid on time. So at 0 days late, it's 1,050. And then the point 4, 1150 means rent is $1,150 when paid 4 days late. Okay, next, y equals negative 10x plus 3,000. Y represents the elevation of a skydiver measured in feet, and x represents the time since opening the parachute. I invite you to try pausing the video and interpreting what this is before I reveal the answer. And the slope means the skydiver is falling 10 feet per second. So the slope's negative 10, falling 10 feet per second. The falling is what makes it negative. The y-intercept means, well, the y-intercept is 3,000, and slope, or the y-intercept, y means feet, the elevation of the skydiver. So the skydiver opens the parachute at 3,000 feet above the ground. The point 300, 0 means, well, 300 is seconds and 0 is feet. Means after 300 seconds, which is 5 minutes, the parachutist lands. Okay, next, y equals 1/3 x plus 55. Y is going to represent the height of Jeffrey, measured in inches, and x represents the time since Jeffrey's 10th birthday, and that's measured in months. What does the slope mean? Well, the slope means Jeffrey grows 1/3 of an inch per month. What does the y-intercept mean? Well, the y-intercept is 55. It means Jeffrey is 55 inches tall on his 10th birthday. What does the point 12, 59 mean? Well, 12 is months, 59 is inches. 12 months after Jeffrey's 10th birthday, which is actually on his 11th birthday, he is 59 inches tall. Okay, next example. Y equals 1.25x plus 8. Y represents the cost of pizza. X represents the number of extra toppings. The slope means, well, it's going to be dollars per topping. Extra toppings cost $1.25 each. The y-intercept is 8. It means a basic pizza with no extra toppings cost $8. What does the point 4, 13 mean? Well, 4 is the number of toppings, because that's what x means, and 13 is the cost of the pizza. So a pizza with 4 extra toppings is going to cost $13. Okay, y equals 55. X. Y represents the distance traveled measured in kilometers, and x represents the time driven measured in hours. The slope is, of course, the number in front of x, 55, the coefficient of the x term. So 55 kilometers per hour. Person is traveling at 55 kilometers per hour. The y-intercept is not written there, but it is 0. That just means the person starts having traveled 0 kilometers. What does 2, 110 mean? Well, 2 is hours, 110 is kilometers, so after 2 hours, the person has traveled 110 kilometers. Y equals 80. where Y represents the total cost of a cell phone bill and X represents the number of texts sent. Now the slope means, well, the slope is 0. Text messages change the phone bill by $0 per text, or texts don't change the phone bill. The y-intercept, of course, is 80. That means the phone bill starts at $80 before any texts are sent. In fact, texts don't tend to change the bill. It's the point 91, 80. Now 91 is number of texts. 80 is the cost of the bill. So 1 month, 91 texts were sent, and the bill was $80. Y equals 30 plus 0.0571x. Y represents the total cost of an electric bill, and X represents the power used in kilowatt hours. The slope is 0.0571, and that means the power company charges 5.71 cents per kilowatt hour. And the y-intercept of 30 means the power company charges a service fee of $30. That's just the fee for being hooked up before you use any electricity. And then the point 1,240, 100.80 means that 1 month you used 1,240 kilowatt hours and the bill was $100.80. Okay, Y equals 3,500,000 plus 0.02x. Y represents the total distance between islands, measured in centimeters, and X represents the years since 1950, and that's measured in years. The slope of 0.02 means, due to plate tectonics, the islands move 0.02 centimeters apart each year. And the y-intercept of 3,500,000 means the islands are 3,500,000 centimeters apart in 1950, which is 35 kilometers. And what does the point 73, 3,500,000 1.460 mean? It means that in 2023, which is 73 years later, the islands are 3,500,000 1.460 centimeters apart. They're not moving very fast. Next, Y equals 4,600 plus 52x. Y represents the population of Springville measured in people, and X represents the years since 2000 measured in years. The slope of 52 means the population of Springville grows by 52 people each year. And the y-intercept is 4,600. What it means is that the population of Springville was 4,600 people in the year 2000. Now the point 23, 5796, well, the 23 is the year and the 5796 is the number of people. So in 2023, which is 23 years after 2000, the population of Springville is 5,796 people. Okay, now let's look at interpreting some things off of a graph. Let's name the ordered pair at point A. By the way, when you're reading a graph, I recommend reading the title. It says average temperature. Read the x-axis. It says day. Look at the numbers. It counts up 1 through 7. Look at the y-axis, temperature in degrees Fahrenheit, and look at the numbers. It goes 35, 40, 45, 50. Okay, so we've got temperature compared to days. A is located at 2, 35. At day number 2, 35 degrees. So on day 2, the temperature was 35 degrees Fahrenheit. B is located at 7, 49, which means on day 7, the temperature was 49 degrees Fahrenheit. And part 3 asks for the independent and dependent variables. The independent variables, the input, it's the day on the input axis or x-axis. The dependent variables, the temperature. Identify the graph that represents the altitude of a skydiver just before she jumps from the plane until she lands. Well, if it's just before she jumps until she lands, she's going to start up high and come down low. It's going to have to be graph B. Mrs. Blackwell's students recorded the height of an object above the ground at several intervals after it was dropped from a height of 5 meters. Write a set of ordered pairs representing the data in the table. Well, the set of ordered pairs, not too hard to do there. 0's at 500 centimeters, 0.2 seconds is at 480, etc. Number 7, draw a graph showing the relationship between height of the following object and time. So I'm going to go ahead and scroll that up a little bit. And I've got there we go. it looks like at 0 seconds 500, and it does have a nice little curve down, so it's not linear. It asks us to identify the domain and range of this function. So let's, I got to pull that down from up here. Oops, I did that wrong. The domain is the number of seconds that are possible inputs. Let me drag this down where we can see it while looking at the graph. The domain is between 0 seconds and about 1.01 seconds. It hasn't quite hit the ground after 1 second. It's still 10 centimeters off the ground. I think when I calculated it earlier, it was 1.0102 seconds. And the range is between 0 centimeters and 500 centimeters. Is this function discrete or continuous? Now, the function itself is continuous because the input variable is time. If we were to take a measurement at 3.3 seconds, there would be a position for the ball. Well, we weren't told it was a ball. There'd be a position for the object. We have discrete measurements because we had to pick a time to take a measurement, but the function is going to be continuous. All right, look at the title of the graph. It says dog walking. X-axis, number of dogs walked, 1 through 8, and amount earned, 5 through 35, counting by 5. What does A mean? Well, A is at 1, 5, and it means when you walk one dog, you earn $5. What does B mean? Well, B is at 5, 25. When you walk 5 dogs, you earn $25. Maybe I ought to fix that real quick. When you walk 5 dogs, you earn $25. And the independent and dependent variables are independent is the number of dogs walked on the input axis. The dependent is the amount earned measured in dollars. The graph below represents Teresa's temperature when she was sick. Describe what's happening in the graph. You can see the temperature going up and down over time. That could be caused by different things. Maybe she's taking some pills to lower her temperature. Maybe she's using a ice pack to try to lower her temperature. But as the temperature comes down, maybe the medicine wears off or the ice pack warms up, and then the temperature goes back up and have to redo it. And then this one over here looks like the graph below represents an altitude of a group of hikers. Describe what's happening in the graph. I would say the group of hikers start climbing up from where they parked their car, and then they decide to go back to their car for something, and they go back out on the hike. That's one possibility. Let's go into the assignment. And I won't preview the assignment this time. Let's just go ahead and work on that.